Okay, so simplifying down a trigonometric expression. On this one, the first thing I notice is that we have negatives involved. So as we have these negatives involved, we're going to use the even odd identities to get rid of the negatives within the function. So the first thing we're going to do is we have cotangent of a negative. We're going to move that negative out in front. So we can say that's the same thing as the negative of the cotangent of positive x. Next, cosine. Cosine of a negative, we can simply drop the negative and make it a positive. So multiplied by a cosine of x. And then finally, to get rid of the last negative, we have a negative inside of a sine. We're going to put that negative out in front. I'm simply going to say that's subtracting sine of x. All right, the next thing that I'd like to do as we simplify this down is I would like to get rid of my cotangent and rewrite that in terms of sine and cosine. That's going to require a quotient identity. So we have cotangent is going to be cosine divided by sine. I'm going to leave the negative out in front for now. So we have cosine of x divided by sine of x multiplied by cosine of x. And then we'll bring along the sine of x at the end. Okay, from here, we can simplify this a little bit more by combining these into a single fraction. Instead of having a fraction multiplied by cosine, we can visualize this as dividing by 1, right? Make that into a fraction, and then multiply our numerators together and multiply our denominators together. So we have cosine squared of x divided by sine of x minus sine of x. Now, to make this a single expression, instead of having two separate terms here, basically we have a fraction minus sine. Let's make that into a single fraction. So to do so, we would need a common denominator. So I'm going to visualize this as being over 1, and I'm going to multiply numerator and denominator both by sine of x to get that common denominator. This will make negative cosine squared of x divided by sine of x minus sine squared of x divided by sine of x. Now that we have a common denominator, let's make these into a single fraction. So we can say negative cosine squared of x minus sine squared of x divided by sine of x. Now looking at that numerator, we have some squares, right? We have cosine squared and sine squared. That's leading me towards the Pythagorean identities. So sine squared plus cosine squared is going to equal 1. So to make those both positive, what we can do is we can remove that negative, call it a common factor here. So we get cosine squared plus sine squared with a negative out in front, all divided by sine of x. All right, therefore, cosine squared plus sine squared, same thing, just reverse the order here. That's still equal to 1. So it's negative 1 times 1 up in our numerator, which makes a negative 1, divided by sine of x. Well, that leads us towards a reciprocal identity. So 1 divided by sine of x, 1 divided by sine of x is going to be cosecant of x. That negative can simply come along out in front. So we're left with cosecant of x, or rather negative cosecant of x, which simplifies this down into a single trigonometric function without a fraction. So as you get going on these, remember, get rid of the negatives from the inside using the even odd identities, then replace everything in terms of sine and cosine. Sometimes that's quotient identities, sometimes reciprocal identities, and then work some algebra to make these into a single function. Whenever you get squares involved, be thinking Pythagorean identities. And then usually at the end, you want to use reciprocal identities to make sure that you have a single trigonometric function without a fraction. All right, good luck to you on these.